Hello everybody, this is scratch building, and what scratch building is, it is possible to do and you too can do it. Basically scratch building, it's building a droid using materials that you can find in a craft store or hardware stores, basically any stores that sell stuff and even junk. You can look in your trash and you might find something. There is some assembly required, unfortunately. Some band-aids are required and maybe some high medical costs for some people. It just depends on your safety precautions. I am Ari Stone. You can find me on the boards as Stoner529. I have a website. It's buildinr2d2.com, and then my YouTube channel, which is, you see it up there, Building R2D2 by Ari. And I basically video log everything that I do when it comes to scratch building this thing, because I know there are people out there that they just want to try to scratch build everything that they possibly can without having to buy parts or 3D print them and things like that. So why did I want to scratch build? Number one was the challenge of scratch building, because it's not the easiest thing in the world to do, and for some reason there's just a thrill for me to be able to say, yeah, I made this part, I didn't buy it off of somebody, it wasn't pre-made. The materials, they can be cheaper at times depending on what you're doing. And it's an excuse to buy stuff. So, I've acquired routers, Dremels, jigsaws, band saws, table saws, all sorts of good parts just so I can build this. This is what he looked like 2 years ago. It's a slow process, scratch building and all that stuff. But the reward for it is well worth it. There are... For some reason my computer wanted to freeze on me, and now it's not going to the next slide. There we go. All right, so the materials that we have are plastic. You can see there's styrene right there. That's what I used to make, I believe that is the octagon port, as you can see. Cut that out by hand, drew it out by hand. We have wood, a couple different types of wood you can use. There's MDF, although, if you're building a frame, we all know don't build it out of MDF because it'll last you about 10 seconds, just enough to put some weight on it and watch it crumble. Even though it's strong, it's not made for building droids. We also have plywood, which is, if you're scratch building a frame, the best thing that you can use is the plywood. Baltic birch is the best that you can use for that. It's really tough, it's strong, it's made really well. You can get it in 5x5 sheets. Some places might have it in 4x8. It is a metric kind of thing. If you can find it in 4x8, you're lucky. I'm lucky in Pittsburgh, where I'm at, I can get it in 4x8. And then there's just planks. And what I mean by planks is you can get like large sheets of not really hobby wood, but like poplar, rosewoods, that kind of thing. Come in long planks that you can use, and they just come in handy because you can just cut them down to size for working in certain things that you want. So we also have metal, and a lot of parts, they're made out of aluminum or just for scratch building sheet metal, because you need to be able to build everything unless you have a lathe to turn things and all the proper hardware for that. A lot of guys will put everything on a CNC router. That's cheating for me a little bit, because I figure, you're programming something and it's turning itself, doing whatever. And then objects. What do I mean by objects? We have a mouthwash cap. You're like, God, what could you make out of a mouthwash cap? And hollow projectors, the cones on those are certainly mouthwash caps. This cap that you see here was the exact dimensions, where from the bottom up, if you cut it at a certain place, if it's equal for a hollow projector cap. We also have spheres, which are these right here. You get these at craft stores. They're handy for making the cowls and all that. You can use them for making radar eyes lenses. Are they to spec? No. Will anyone notice? Probably not. So these are just a couple of the things that you can use that you can build stuff out of. I've got a bunch of wood parts right here. These are spares left over if you guys feel like passing these around. Here. Got it? That's a basically a wood logic surround that I had made. Tools that you will need if you were scratch building. Definitely a hobby knife, and a really sharp one. And don't forget Band-Aids. You want to, PPE would be good if you don't know what PPE is. That's personal protective equipment used. I'm in the drilling industry, so they preach safety a lot. You want to be safe about what you're doing. You want to pay attention to where your hands are if you're using routers and anything that will cut wood at a rapid pace, because it will take off your limbs. And we have had a couple of builders had their limbs taken off and had to get them reattached by building frames. So, and they're experienced, and you put your hands in the wrong spot and you might lose a finger. You have variable speed Dremels. You don't want to get anything that's just one speed, because you need different cutting speeds for different materials. I hear people, oh, Dremels will burn out real fast. I'm lucky mine hasn't burnt out. Maybe that's because it's a variable speed and I'm able to slow it down, speed it up based on the material I'm working on, and I think that's an important factor. As the saying goes, you do get what you pay for. If you buy a cheaper Dremel, you're probably going to get that use out of it. You buy a $50 Dremel, you might last a year, might last less than that. Measuring tools. I got all sorts of rulers, digital calipers. Those definitely come in handy. Digital angle finder will help if you're building a frame, or you can have your skins already ready and just kind of line things up that way to figure out where stuff go. A pencil. That's kind of common knowledge, but definitely a pencil, because when you make mistakes, you're definitely going to want to erase some stuff and redo it. I got a pair of friction dividers. I don't know if you know what those are, but they are basically, it looks kind of like a compass, except it has 2 points on the end, and you can just use it to move it about to get equal distances of stuff making points. So that also comes in handy. I've used those to mark things, like I don't know if you can see on here, I've got like a, this is another sphere, but there's a small circle that I have going on in there, and I use that basically to etch a little circle, things like that. You have your compasses, of course, because you need to draw circles. Believe it or not, if you're scratch building, geometry is involved. So I had to go back into the 8th grade all over again to figure out how to make certain things and find true shapes. So it's always an experience. So when kids say, when am I ever going to use this? You're going to be like, well, you're going to need it to build a droid. So math, it's important. I also got variable speed routers. I didn't go cheap on my router. I bought a decent one for about $500, a good table saw. It's a Bosch. Haven't had any problems with it. It's variable speed for the same reasons that you would have for your Dremel. A jigsaw, never know when you're going to need that for cutting out a frame, things like that. Bandsaw, same thing for a frame. Drill press, never know when you're going to need to drill holes. A drill press can come in handy if you decide to make your very own logic surround bezels. I tried, I was half successful. I wound up buying some from Joy Monkey, of course, because they were a lot better. Some of the things that you would want to do, maybe buy some parts. Tin snips always come in handy, especially when you're working with metal. Thin sheets, cuts right through it. Believe it or not, they have tin snips that curve to the right, tin snips that curve to the left, and tin snips that go straight. Might be a good idea to get the ones that just go straight, but you also have to be careful not to cut yourself when you're working on it, because when you're cutting, that metal will stick out, and as the others bend inward, sometimes you have to chop that off. You need different types of drill bits, step down bits, they also help. Hole saws, that's another thing that I use. So like I said, at the bottom, just safety stuff, maybe respirators if you're working with paint, you're working with whatever glue you want to use, super glue, E600, JB Weld, epoxy. All that stuff can be harmful to your health. Don't be afraid to use it because it's harmful. You just have to wear proper protection and you'll be okay. So, what to build? And what I mean by that is, what parts do you think you can build and what parts do you think you don't want to build and you'd just be better off purchasing them? For me, I made a couple decisions. One was our friends at Granite Earth make a wonderful dome, so I chose to buy the dome because I didn't really think I could scratch build a dome quite as well as I could buy this nice wonderful thing. Unfortunately, I scratched it. Darren wouldn't give me a new one. You know how that goes. It's just, you scratch it, just deal with it. It's called weathering. So when you mess up, just consider it weathering. The other things that I ordered so far would be the Arduino, because you know I can't really build that myself. I probably could if I tried. And of course the TCs, which I got, but it wasn't assembled, so I got the whole parts list, put them all together. Didn't have too many failures with that. It's fun learning how to solder, and now I've learned after taking this soldering workshop here, you don't just tin your soldering iron once. You constantly tin your soldering iron to make sure it has solder on it. So who knows how many different types of soldering guns I've gone through. But that's always one thing that you need to pay attention to when soldering in. If you are scratch building these things, don't be afraid to try it. If you think you can't do it, there are plenty of builders on the forum that can help you out and say, well, we're doing this wrong and that wrong. And believe it or not, a lot of people that think they can't scratch build, they really can once they get down to it and they realize it's not as bad as they thought. They just have to get down to it and start cutting. It's kind of like the dome. Everyone's like, I got my brand new metal dome. I'm afraid to do anything with it. Well, unfortunately, you're going to have to do something with it. Otherwise, it's just going to sit there in your house forever collecting dust. And mine's got a little dust on it because it's looked like this for 2 years as I slowly build parts. Why order parts? Skill level and desired look. So you might think that, like I said, like with the dome, I ordered this because I knew it would look good, and it's definitely not something I want to try scratch building, although I probably could. I might be able to get it fairly close. And time savers. Scratch building a dome might take quite a long time to do because you got to find the right materials. A big old bowl that's probably 18 inches, some modeling clay, then you have to take the time sculpting it out. And it's almost, I would say, like the old domes that you just were able to buy the dome, but you kind of had to put the pattern on and cut everything out. To my understanding, I haven't read that much, but that's what the old domes used to be. So parts you can make, I would say probably all of them. It's just a matter of how you can do it. Like I said, I bought the dome. Here are a list of the parts that I have so far made by hand. You see you've got your power coupling right there, the octagon port. These are all cut out from styrene, some of it's wood. There is the not the dome topper, but the small ring that goes around the dome. I basically had to find a washer and step down bits and just slowly step down. You see the picture right below that. That is a hole plug, which I'll show you a little bit more on the next slide. All that is, if you widen, I don't know what the newer domes are like, the hole that's right in the center of the top, if you widen it just a little bit, these hole plugs will basically pop in and stay. I know some people sell ones that, you know, it's just a regular bolt that from like the satellite dishes, it'll thread right in and you can do that. I don't know, this one's almost comparable. You just pop it in and that's it. And you can probably take it right out without having to do anything. You see I have my PSIs down over there on the corner, or I'm sorry, in the middle. And those are just simply made from the holders are PVC piping. A lot of people will think, well, there's two different sizes, so you know I need to get two different sizes. That's not true. We'll cover that a little bit later, and I'll show you how I did that. Cutting boards, that's a great utensil to use for the color over here, just to like kind of diffuse it a little bit. You see I got my skins right there, which I drew everything out by hand because of the way I had to cut them out, drew them out by hand. My radar eye and the lens. Kelly Kreider's method right there. He has that pattern. You can use that. I had one moving holo projector. The servo has since broke, but scratch built the casing for that. Over here, you see that's a holo projector cap that I made. There are my wood logic display bezels. As you can see, I cut those out of wood using a router and a chop saw. We have over here the lens that was from the radar eye. You see it's kind of getting painted there. The one thing in the middle, that's a hole plug. You can find those at your box stores in the hardware section. It's just, they're really small, but they fit perfectly right on top. I have some wood, what are those? The coin slots. And then there was the start of the cowl that I made for the my holo projectors up top there. We see up top, that's the center wood frame. I made templates out of MDF. I probably made about 3 templates. As you learn and figure new things out, that eventually you want to make it differently and better. We've got our vents that are on the side there. Those are all cut out of styrene. I did mine a little bit differently than how everybody else does theirs. We got the coin returns, which are half styrene, and they are also half metal. I can't remember what type of plate I used. We've got my wood large data port that you see there. I decided not to make my own Lazy Susan and just use Granite's Earth. As you know, maybe you don't know, Lazy Susan, it fits inside of the dome, makes a turn, but theirs are already pre-drilled. It's basically the same Lazy Susan you would buy. it's just easier to get. They've got it pre-drilled, makes it already easier, not messing up your bearings or anything like that. And then of course a side plate, pretty easy. So we are going to get down to it. We got logic surrounds right here. I already passed one around. This was it, you saw, made out of wood. Here I am. This is just basically cutting in slots and grooves. You see over here on the other slide that I got that I'm holding there, it's kind of hard to see with the way this projector is, but that's just 1/4 of the piece that I made. I had to make a bunch of different slots of those. You see the one at the bottom, it's kind of hard to see here in this as well, but that's just, I made a bunch of long pieces and then slowly cut them out. You have to learn angles and things like that. A little bit of geometry is involved. It depends what kind of tools you go. Some chop saws, they might only go up to like 40 degrees. Watch your hand placements. It's good to get clamps to hold things down while you're using chop saws. That way you don't have to put your fingers right in the way like I did. You'll see in my videos, my fingers get really close to some of those things, and I still have them. I got lucky. I didn't chop anything off yet. Wood glue is also your friend. When you make a mistake, you can just glue it together again. So here they are. Basically, you have to cut them back down to size. You see, I made it really large, but that's the way I had to do it. Chesting out to see how it fits in the surround. It's a good way to glue it together too. You just put that in the surround and it'll hold it together, and you know you have a good fit. Cut the sides down for it. And then what I am missing that you don't see in there is something to hold it to the dome. So I actually had to make some pieces that are round, just beveled a little bit and curved. That way it fits inside the dome properly. You see on the lower slide there, we have the rear logic display. That is also the bezel I made. So you know you have to learn how to cut circles with the router. So just make yourself some templates and some jigs. That's what I had some, if you'll see my videos, I made took a piece of plastic, cut it up into sections. That way I could have a 9.5 inch or 9 1/4, whatever the actual diameter is for those, since they're a little bit bigger than the dome. You see there's like almost the final product in the very bottom slide right there, that logic surround. Wasn't too hard to do. Like I said, I had to make something to hold it onto the dome. So I did that eventually. This is the radar eye right here from Kelly Kreider. You can find that pattern. It's in the wiki somewhere on astromech.net. And I cut it out. I pasted it here. You can see just cutting it out. I used zinc. It's I don't remember what the thickness of what it was, but it was easy enough to cut with a pair of tin snips. You just have to be careful how you're doing it. There's 2 pieces that are actually there. The one on the bottom is separate. That goes on the bottom of the radar eye. Use a drill press. Basically doing that, you're cutting out the circle. You could use a hole saw, but there isn't a big enough hole saw that I could find. And if you're cutting it flat like that, it actually doesn't work, because it might be better to cut out that piece after everything has been in shape, because really it's 3 inches, but you're looking at 3 inches it's actually curved. If you're doing 3 inches straight, it comes out differently than 3 inches, so it's curved. So again, a little geometry. See at the bottom slide, using the Dremel to cut out the slot there. And then the one right next to that, you had to make the radar eye, the center portion of it, so that's round. Had to figure out a way to clamp it down and hold it. So I had some C-clamps there that moved in and out and locking. That one was a challenge to do. It might have been better to make part of that out of styrene, mix and match some parts. Didn't do it, but it still turned out okay. This is the inside. I basically had to JB weld some of that together to make it stick. You could see putting on the inside of that radar eye, the surround there, the inside. Remember, if you're doing that, because it's actually curved, it's not a totally round piece. It has a curvature to that as well, that circle that you're putting in. The one on the bottom there, it didn't quite match up, so I had to fill it in with a bunch of JB weld and sand it. And the good thing is that it's scratch built. If you're doing a weather droid, it looks perfect, and you can just consider R2 as having damage, because he's gotten blown up quite a bit. And you can see on the slide next to that was the side piece that I made. I mixed and matched parts for that. I had some styrene that was just about the right thickness that I made a box, attached it to the side, then attached the styrene to the side of that with, I don't know, like super glue maybe, or more JB weld, I can't remember. So we have the radar eye lens. People often ask on the forums, what can I use for that? You'll see anywhere from old TV projectors to buy one from the junkyard. If they're not available in the junkyard, that's, as I said, part of the reason we scratch build is, let's say you're waiting for a part. War Parts doesn't have this or that, and you're like, well, I want it now. Or this isn't produced. Well, you know what? If you want it now, and you want all aluminum, you could hire somebody to do it for you. Or you could just, in the time being, find something, build it out of plastic or sheet metal until you get the part you want to look right. In the meantime, you'll have an operational droid. So basically, I marked it, I cut it out with the Dremel. Be careful, Dremel, depending on your speed, will melt plastic. Make sure you have the right bit on there. I melted mine a couple times, took a couple of tries, and got some head shaking like, yeah, I've been there, done that. The smell is wonderful of melted plastic. Remember, it's kind of toxic. I painted the inside of the radar eye black. I didn't paint the outside of it. That way it shines on the outside. I used a flat color. I don't think anybody cares if you use flat or gloss. You're not going to look at it. They're just going to be like, oh, it's R2. Looks really cool. So there I am. I'm putting it on, seeing how it fits. Once I painted it all up on the inside, I'm just going around touching up with some black paint where the lens meets up with the radar eye itself. So here is the infamous hollow projector cone. That thing was fun to do. You have to make 3 of these things if you want to do it. I can say if you're taking this droid to go out in places, you may want to use resin, something that's more durable. These are easy to build, but they'd probably do better in a static format, or you can make them move, but if you're doing like a display for your house where you know kids aren't going to be grabbing things and all over the place, it'd be better, because this one kind of broke off real easily, as you see. But I mean, the way it's designed, I could probably glue it back in. I'd just stick it back in there like that, but might make a kid think they broke it and get upset and cry. But to build those, I cut a mouthwash cap off. It's not just any mouthwash cap. There's a certain one you have to look for. And you saw I had that in the beginning. I got mine, I think, from, I want to say our local grocery store had the right type. And you have to look at several different mouthwash caps, believe it or not, just to find the right one that looks right. And that's what I found. As you see, it's rigid, but those aren't the ridges that we like. And it has that little grip on the side there for your hands. So you can go to the store. I believe Paul yesterday talked about Squadron green putty. You can use that. It's filler. I use Testra's putty. And you see in the bottom picture there, I basically just filled in this whole cap with putty, sanded it down, let it dry a little bit. I used wet sanding technique. Sanded it again till it eventually looked like it did on the left. I think that would be, I don't know, my left. You're right. It basically looked like that. Then I found styrene strips, which were, I believe, 0.010 by, like, I don't know, like 10 inches long, something like that. Just really thin strips and small thickness to them. We'll go back to that. And I basically had to glue these strips on. If they're glued right, they'll stay on, but remember, you are also working with filler on there, so sometimes they will come off. Again, it's a droid that's going to look dirty anyway, so if something falls off, it's R2. He's now 60 years old, technically in chronological order, and he's never had a single upgrade to him, believe it or not, and he looks the exact same. I'm sure something on him would be broken, although they've shined him up quite a bit. But I basically had to do those, put those on. There's like 36 of them, I think, for each cap. So I found the best way to put them out. Instead of measuring them out equal distance, you just put them on in a quarter, then divide that by half, then by half, and by half, and each time until you come out with 38 of them. Worked out fairly well. This is designing the actual hollow projector cones and stuff. So you see those at the very top, those are what the friction dividers look like. Right there, hard to see, the silver things. Used my hole saws. You have to be careful drilling out with plastic because those are sharp and they cut you. If you just kind of go slow with it, it's going to slowly basically etch out a circle and eventually cut through it. I got my Dremel there because the way I had to cut the middle or the bottom cowl, it isn't perfectly round. It's got like an odd kind of shape to it where it's almost like 4 holes cut out and it leaves the center portions of it. So I had to smooth out the centers of that, make that look pretty, and as well leaving a hump. So the way I had to do that was quite a challenge, and that's why I had, like, on this, I don't know if you can see, I got like 4 holes because that was essentially telling me where I needed to put a drill bit in order to slowly drill out each single hole of these to make it look proper. Sometimes I switch it from the front going through the back. And you see the completed one there. I used a PVC pipe like this to attach that front hollow projector, the hollow projector caps. It's got this bevel on it. I've only found these at Home Depot, nowhere else. I don't know if you'd be able to find them anywhere, but one of these will fit on the inside. The other is basically to go inside of the hollow projector cap. And then the other section will fit inside of this right here. and that'll hold on the cabochon. I don't know how to pronounce those, but that's the little magnifier that emits the light. So hollow mounts, if you want everything to work properly, scratch building, you have to find a way to mount it. So good thing I had my sheet metal. You see on the left side picture, I believe the one over here, that I had a servo. The servo broke at DroidCon 2 years ago. It didn't last long, but you know, it's all part of droid building and having to fix it. I haven't fixed it yet because I haven't really finished my droid, but at least I know I can do it and it works. I had to basically look at how Bob C did their mounts and stuff like that. And I said, well, I think I can make something like this. So I took a sheet of plastic, put it over that, and used metal as a base. It cracked a little bit, but it does its job. It serves its function. Made some small circular discs. That way you can see for the actuators on there. I only made mine move up and down. I felt that's all that I needed for it. Most people, in my opinion, aren't going to pay attention to which way your droid light goes up and down. They're just going to be like, wow, that's cool. And then for static mounts, I basically just cut a diameter, would be, if I could say, maybe like the same size of this right here, that fits through a hole and it holds it pretty good, and then just clamp it down with your captive studs from the inside, so you're going to have to mark that. We have a center frame. As we were talking about, if you want to scratch build your frame out of wood, good thing to do is build it out of MDF first. And you see that right there. I had, prior to a digital angle finder, I had this little guy right here, which it worked, but it'd be easier if you had something better. Digital, give you a more accurate reading. I measured everything out. The more frames you build, you'll learn that it's easier to make the middle ring because it has all the slots already in it. There are a couple slots you won't use, but most of those slots go all the way up the whole side of the droid, with the exception of the sides. There's 4 slots on the sides that don't go all the way up. But you can use that ring to cut out every slot there is and then just extend them out. So it's always helpful. You can use one upright to cut all the rest if you make that work. It's just a matter of knowing how. I show some of that in some of my videos. You see there on the bottom, that was the base cut out using a router. It's always good to have put up jigs and things like that to keep your router straight. And you see all the, I lined them up right over there, all the uprights just for that. People wonder, can you cut skins? You certainly can. If you find a supplier, like we have TPI Plastics over in Pittsburgh, so I was able to go and buy sheets of .040 styrene with hips. Works really well. There's 2 ways to cut these out. You can cut out the lower skins first. Make sure, remember when you're cutting in the inner skins, the diameters and the, I shouldn't say diameters, but the insets of everything is always a little bit smaller than everything else because those always hold all your external parts. Like you have, this here would be the coin return. You know, you got to make sure everything will fit in right like that. Same with like your vents and things like that. These are what I made out of styrene. And when they look at it on the websites, they're like, well, how do we do this? Is there an easier way to cut these out? What do you mean by shifting panels? Well, the reason people shift panels, as you can see in that picture over there on the top, I have it all drawn out. You could cut it out and you could spend time cutting out 1/8 of an inch on one side and 1/8 of an inch. I'm not exactly sure, the diameter might be 1/32. Or you can just cut out 1/8 of an inch on one side and then a bottom, and then you'll be left with a square. And then you just have to cut around that. So in order to do that though, you have to draw out your whole styrene skins by hand. You got to get a tape rule, measure, all that stuff. And you can see how it's all laid out there. I got all the parts down here for that still. So just, you know, pay attention to what you're doing and you can make your skins. I'd say the full sheet of styrene I got was $25, and you can make a full set of skins from one sheet if you do it right the first time. There's the key, do it right the first time. Most of you probably will not. I know I did not, because you messed up and you say a few choice words like Yosemite Sam. When you put these on, you're like, didn't quite work. Large data port, that was a fun one. I wanted to see how to figure out how to cut this thing, because as you know, it's beveled on many certain edges, and how do you bevel something that's also rounded, making it out of wood? So basically I had to use a router to cut out the round portion of that. And then we had to figure out how to bevel it. So these are them right here. You see if you hold it the profile, it's got this bevel right here. Well, the best way I could think of to do that was to make a jig that was angled in the direction of how it would basically hit a router at an angle. You want to make it sturdy. Mine wasn't as sturdy as it should be, so it would cause a lot of chatter, and it is a router. You have to be careful of your hands. If you're moving wood parts and your hands are on something that could get caught, it could get pulled into the router and you won't have your thumb or finger anymore. So that's where safety comes in handy. You always have to watch at hand placement, and routers are very scary. You can see my hand right there going into the router. We're cutting off that bottom piece. So I use the same method to cut the top and the bottom. You just want to make a jig that's angled in. Maybe you guys have a better way. I'd love to hear it if you could think of something. But this is what I did, because there aren't a lot of wood products out there, I don't think, if any. But you can do it if you have the right tools. Coin slots. Some people's dog eat their homework. My dog ate my coin slots. So he gets a hold of anything. Huskies, they like eating wood and whatever else you put in front of their face. If it's not food, they're going to eat it for you. So don't get used to your couches either. But those are, again, made out of wood. You basically have to draw out a whole pattern for those using a table saw, essentially in reverse, so you can see where your lines are at. You know, you're going one way with it and you see the picture on the other side over there. You're basically filling in the grooves right here. Doesn't matter how clean they look or not, because it's going on the inside. You're never going to see it. You just have to pull that back and forth until you got a groove cut in there. I'm sure they make some sort of cutter for that, like for, I don't remember what the name of it is, like if you're making the, not dovetails, but what's that? Dado. Yeah, those dado cutters. I don't know if it'd be the right size or not for those. You could probably use one of those, but that would have been another expense, and I figured this way will work. And then, you know, you have to figure out you're angling this table saw. Well, if your table saw only goes from, like, say 45 degrees, you got to use geometry again and figure, well, this angle is this, what's 90 degrees, complementary angle, this and that, and you're like, oh. Make practice cuts first. That'll tell you if you have your angle right, and then you could stick an angle finder on and be like, okay, I did it right. If you are using table saws, you have to make sure they are perfectly square, because otherwise you're going to have, my first set that I cut out, one side was actually just a little bit longer than the other as it's going through, because it's just cutting at an angle. It's so slight you couldn't even tell. To make the holes and the slots right down the middle, all I did, I just took a drill press and unconventionally just kind of slowly drilled in and just moved it back and forth like you were like having a router inside, or I guess you could say almost like a CNC, but it's all manual. So, you know, just be careful. Coin returns. There are patterns for those that are online that you can also use. I used a glue stick, glued it to a different type of metal that was really thin and bent a lot easier. I decided I wanted the metal look for those, and I could paint the outsides. Plastic, I used plastic. That was the debate what to use for that, because plastic, it's easier to bend. If you're using metal, you all know you have to have something that bends it, usually sticking it between two rollers. Not many people have that. So I have a pair of clamps there that I'm able to bend this metal with. Got the hammer, that way it leaves you a cleaner square edge. You just sit there and tap it with the hammer quite a bit and it'll square itself out. The bottom picture there you see is me actually cutting out this inside right here. So you just cut that out, you line it up, and I use super glue. And we all know sometimes you're mixing different types of glue with different materials. How well will they hold? If your parts are really clean, super glue will probably bond very well. And then you will have to figure out how to get your fingers out of it. Because I glued my fingers a couple times to this stuff right here. But even so, like on the insides of these, they look rough, but the way these are positioned inside of R2, unless you get down on your hands and knees and look at it with a fine-tooth comb, no one's really even going to notice or pay attention to what it looks like. They're just going to see a completed droid. Side vents. You can also build these out of styrene, different types of plastic you can use. I used my .040, and this is one of them right here. These are rounded, so if you're able to bend the plastic, it definitely helps. And you can see it does have that curvature to it. I did one of these a little bit different to where hopefully I can set it in and it'll hold itself in place with the way the R2 is designed with the inner and the outer skins, we'll see. But some people, they make boxes and make the inside slots out of small boxes. I decided I was just going to stack up a couple of layers of styrene and just cut them out, and that's what you see me doing on that bottom picture there. The top one is me putting some plastic cement down and putting a piece of another styrene on top of that and just slowly going around each square with a knife, hobby knife, and slowly cutting out those grooves. And I think this one, it took a total of 2 layers to get it to almost the exact thickness, and I don't think anybody would know a difference, even though it's not to spec. You're not going to know. And since it is rounded, you have to remember that you got to cut out round pieces. So if you have like leftover stuff from cutting out a frame, that'll help. You can just use that as a guide. It doesn't have to be perfect towards spec, because I believe like the 1/32 doesn't make too much of a difference when you're doing this. Here's more of the side vents. As I said, this is me cutting out that round portion right there. And when I glued it on, because it's super glue, I found it easier to just work in sections when you're gluing this. So you glue a little bit, wait till that glue sets, even though you'll see on that top picture there, that's what I'm doing. That's why it's elevated up like that. You're just slowly gluing it. When that sets, push it down a little further, glue a little more, wait for that to set, and just work in steps, and then it'll hold together rather than you having to sit here and hold this thing while it dries like this, because certain areas can pop up. And then the back of it, the reason the backs aren't on this is when I go to paint, I can paint one thing one color. I'm waiting to paint all at once. And then the others, you can paint a different color and then just attach it. And the octagon ports. So more things that you can actually scratch build by yourself. I drew out the pattern for those and just slowly took my time, cutting everything out with the styrene, again, 0.040 thickness. I think that's almost what the plans call for. The pattern that you see on the right behind me, I drew them out in 2 ways because there really is no method that tells you an easy way to do this. But what I found out is that nothing meets in the middle. It just goes parallel to each other. So otherwise, if you're meeting in the middle, the lines actually are angled differently. So nothing, as you can see in that one picture over there, the one on the right side over here, everything is angled in to meet in the middle, but the other side, they don't meet in the middle. Everything is just kind of like, looks like bars going across. That's actually a proper design for that. And just slowly cut it out. Because it's also angled, like everything else on R2, it's rounded. You have to make the sides smaller than the tops and the bottoms. So the top will be basically one length, and then as it curves, you're having to make curved pieces that you see on the sides there. And then you just take a piece and you stick it on top, and that will be your octagon ports. More stuff out of wood, used a hole saw, a couple different sizes, and you'll get the diameters that you need there. I was using some double stick tape here to hold that in place while I used my chop saw, because it is wood and I don't want to cut my fingers off. I used the drill bit there, as you can see from the hole saw, just to place those circular discs on there. It doesn't matter what the one on the bottom is, because you're never going to see it as long as you just have the right thickness, and even then people won't notice. You just place it in, and that's what the completed version will look like that I have there on that picture. We are coming to the end here. This power coupler, that was probably one of the most challenging things to design. I don't know if you guys want to take a look at this or not. Very lightweight, very indestructible. I think like 32 some different pieces it took to construct this thing. Various thicknesses of styrene were used for it. You basically had to cut, there's like 3 different circles that make this, or maybe 4 or 5. I can't remember looking at the plans. Everything is based off of several various circles. You have to make basically the base. You can cut that out all as one, or you can do as I did there. When you're making this thing, you can see at the bottom there, I have a really thin piece of styrene that was used to go around the edges there. Maybe I could have used a thinner piece. You basically have to wrap that in a loop and just slowly do it. Then you see me sticking up a top piece. The one that was on top, it's just the way it's designed. You have to make piece after piece for this thing. Geometry class time. So when you look at the plans, all you are seeing is a flat view of it. You don't take into account that when you're actually having to build this thing, that everything is looking at an angle. So you have to find a true shape. So you see that picture there, me with my pencil. You have the shape of what it looks like on the plan, and your top view of it looking down, which is basically on the top. You have to convert that and make it what its true shape is, which is just a little bit bigger than what you see in that picture, because it's angled inward like that, so you don't get a true definition. You just transfer that over, draw some lines on that other piece of styrene that you see there, and that's me making the slots or the uprights just for that. More geometry. This is for the cone that goes in the middle, as you can see on the picture on your right over there. I had to build a small little base for that, but I used really thin styrene that's real flimsy, and you basically have to come up with, I don't remember what the angle is for that, but again, got to go to math class on the internet and figure out how to find true shapes to make a trapezoidal little archy thing there. And you basically cut that out and you just slowly wrap it around. Hopefully you get it right using your circumferences and all that good stuff like I have on that piece going around there. I made a little jig for the uprights. That's basically so you could put it in and everything hopefully comes out exactly the same. The piece you see on your right there is me taking more flimsy styrene because it was able to bend, because the uprights aren't at an exact angle. They have two different angles to them, and they're also rounded a little bit. So you just got to figure out all these different ways to make things round and bend with plastic and all that good stuff. So I didn't cut that to the exact size. Why? Because I could just glue it on there with super glue, cut it down later and sand it, and no one will know the difference. Here I am, basically, because it's also rounded, I took the cone in the middle and just slowly took some of those uprights, moved them up and down just a little bit to sand a round thickness to it so I could put them on. And now I sat there, well, how do I find the centers of these things once they're already cut out if you lose your markings? Well, you can just place that cone in the middle of a board like I have here. It's a hobby knife cutting board, and it's got lines on there. As you can see, one at the top and on the sides, you could just line those right up and it should glue fine. These power couplers, they have a little round piece that goes on the bottom. So again, just take some spare wood that you use for other things. You got those round thing, or the angles that are cut out on the inside that you can see there, the little round pieces. So once it's all painted, it'll fill in nicely. And that is scratch building for about your top half of the Droid. Maybe in 2 years I can say, here's how I did the other half. Any questions, comments, criticisms, complaints?
Is this the radar eye that you had in your video?
Mm-hmm.
Very nice. I'll take a look at that.
Everything that you see on these slideshows is all on this dome and all right here. This is one of them that I scratch built. Got this right here, the one that the power couplers were passing around. Those are what you see. Okay. So yeah, it's definitely possible. Yeah. So.